Okay everyone, we'll start today. Can anyone confirm that my voice is audible?
It's audible.
Okay, thank you. Okay, so this week we'll start with the assignment questions itself, and in between when the equations are coming I'll explain on that. So this week it's week 6 and we'll be looking at assignments of previous course as well as the course which was run before the previous course. So we'll start with the assignment questions. So in between I'll be moving on to the R Studio also, so that you can solve that, solve the things in that. So you might have seen the data set which was given in the lecture slides. So I am having that data set also and another data set. So we can work with these two data sets in the present in today's session. So we'll start with the session. So this was the assignment questions last in the previous course. Okay, so they were given the bonds.txt. I think you are also aware of this one because this was seen in the lecture slides also. So they have to check this bonds.txt data set, and this data sets contain two variables, coupon rate and bid price. So we have to find out the relationship between the variables coupon rate and bid price. Okay, so for this one what we have to do is I think we can just directly go to the R Studio. So in the R Studio I will just see the first question. Okay, for the first question it is a text file. During final exam, the R Studio won't be there, Swami Vedavidayananda. So the questions will be the things which you can do without R Studio. Okay. So here now we are having a data set bonds.txt. Okay, I think the data set is visible. This is the data set that you are given with. There are 35 observations. So for these 35 observations it's difficult to calculate x minus x bar, y minus y bar, all the different things. For all these observations we have to see. So instead of that we will see with R Studio. Okay, so this is the first one, my data. So since it's a text file we have to give read.dlim. Okay, so this, I think this was explained in the lectures also. So I'll just expand this one, clear everything else. Okay, so this is the thing that we have to take. If it's a CSV file then you have to do a read.csv. Okay, so it will vary with that. If you have a CSV file like this, then if you have an Excel file then it will be read.excel like that. Okay, XLSX. Okay, so read.dlim is for text data or tabular data. Then I have given file.choose. Okay, so earlier I have seen that you can get these data directly, like you can paste the drive, the location in the drive. So instead of that you can just first choose also. Okay, so what I'm doing is like my data, in the my data I am just saving it. Okay, so in the course of this question we will look at other things what you can analyze with the data also. So first I'll read on to my underscore data. So since it is file.choose, it will go to the location. Okay, so you can just check the location and then you can provide it. So if you are doing this in your own system, then also you can check this one. Okay, check in this way, so that you don't have to paste your location every time. Now, so my data is red, so this is my data. Okay, so coupon rate, bid price. Okay, so in the lectures you might have seen how to select dependent values, independent values, all those were told. Okay, so the one which you are thinking as having less errors, right? That is one of the criteria in which you selected the independent or dependent variables, right? So in this one, the bid price will depend on the coupon rate. So here we'll be taking the x value or the independent variable as the coupon rate and the dependent one as the bid price. Okay, so we have first read this data. Then if you want to see the first 6 entries, you can do that. Okay, similarly if you type tail, can you tell me what will tail give you? You can type in the chat window. Yeah, last 6 entries. Okay, it's 6 entries. Okay, if it's last 6 entries. Okay, last 5 entries, yeah, last 5 entries will come in Python actually. So in Python, if you are reading a data frame and you are giving head of that data frame or tail of that data frame, it will show you the last 5 data. In case of RStudio, it's last 6. Okay, so since similarly if it's head, then also it's last 6 data. Okay, I mean first 6 data. Okay, now if you want to find out what are the data types of the columns, so it will show you like this: how many observations and how many what is the data type of the data. So okay, so this is the data type, and if you want to see the summary of the data, so this will show you the distribution of the data, its minimum value, maximum value, then first quartile, median, mean, third quartile. I think I have explained about quartiles in the previous lectures. So all these values will be seen by summary. And if you want to just plot and see what it looks like, you have to give plot, and the x value can be given like my data dollar coupon rate, then my data dollar bid price. Then if you want to give the title, you have to give like main equal to this one, x label coupon rate, and y label bid price. So if you do in this way, you will be getting that okay graph like this. Okay, so this graph, in this graph there are outliers here, then the rest of the things are showing a linear relationship. So the details about this was told in the lectures, so we will move on to the questions actually. Now if you want to build a linear regression model with this, you have to use the LM function. Then you have to give the formula here, bid price tilde coupon rate and data my data. So another way is like you can use the same function, this was also explained in the lecture. So you have to give it like whatever your name, whatever is the name of your data, dollar bid price tilde then my data dollar coupon rate, and then you don't have to give data equal to my data. Okay, these are the two ways by which you can do. So if I run this particular thing, you will be getting model as built, and this is the model. So right now it will be showing like this. Okay, so then one thing you have to see here is that I have given row dot names equal to 1, meaning like it's taking the index values or row the first row as the index value. So you can see in the data there is a first column here which is given 1 2 3 4 like that. Okay, so if this row dot names equal to 1, that means that the first column will be taken as the row numbers. Okay, so if this is not here, then, and if I am just running this particular thing, okay, so just wait a moment. Yes, so if I run this particular thing, so it's asking again. So if I open this, the case also will be coming and a separate index will be created. Okay, so to prevent that, anyway we don't need that, because this is just a serial number itself, same as the index number, so we don't want a repetition of that. So we are giving like row dot names equal to 1. Okay, so I'm just saving, and this is our summary, and we have plotted it also. Okay, so this is the summary of the data we have seen. Now summary of the model, if you are seeing, you will be getting this whole thing. Okay, so LM, formula, bid price, coupon rate, and the residuals are shown. Okay, the value of the residuals, so how it is varying, and the coefficients, intercept and coupon rate, which will give you that the bid price equal to intercept plus coupon rate, this value into the particular variable in coupon rate. Okay, so these two coefficients are there. Estimated value is 74.78 and 3.0661. The standard error of this one is 2.8. so that means that this particular value plus or minus this value will be coming. The variation in the intercept and the variation in the coupon rate is given. Then the t statistic value is given. Then the p value also. So the p value here is showing us this much significance, level of significance is given by these 3 stars. So in the first one, the level of significance is this much. Okay, so it means that beta naught is not equal to 0. So you are rejecting the hypothesis, and here also beta 1 is not equal to 0. Then also the null hypothesis is rejected. So in that case, in the whole equation it will be coming like beta naught plus beta 1 into x. Okay, then the residual standard error is given, then r squared value, adjusted r squared, and f statistic with the respective p value. Okay, so this whole thing will come when you give the summary of a model created with this LM. Okay, now these all things were given in your lecture slide, so we'll come back to the question. So this is the question actually. So what is the relationship between the variables coupon rate and bid price? So now you can tell me the answer. So you have seen it right now, right? So tell me the answer for this one. If you want to check the RStudio once again, I will go to that. You can tell me the answer for this one. Okay, one has put D. Which is the independent and dependent variable? Swami? Okay. Yeah, C. Yeah. So everyone is right. Bid price. So if you see here, bid price is the dependent variable and coupon rate is the independent variable, and the values are 74 is the intercept, so that is beta naught, and beta 1 into x. So 3.0661 into x. Okay, so this C is the answer. Okay, bit price equal to 74.7865 plus 3.066 into coupon rate. That is the answer. Then you can tell this one, choose the correct option that best describe the relationship between the variables coupon rate and bit price in the given data. How can you find it out? You have to see the correlation. Okay, so for that I will move on to this one. So this is the first question. Okay, just I'll rerun that again. And relationship. So relationship you want to find out with correlation. Okay, so for correlation in RStudio, this is the value COR. Okay, so correlation between the coupon rate and the bit price. So here I have saved it in the name bonds. That's why it is coming like bonds dot coupon rate and bonds dollar bit price. Okay, so if I run this particular thing, the correlation is this much, 0.8669743. Okay, so directly you can find out the correlation, or you can use the method which was described in the last lectures. Okay, so since right now we are dealing with data sets, we are directly finding it out since the data is little larger. If you are having smaller number of observations, it will be easier to find out using pen and pencil. Okay, yes, so from this answer, what can you say? You have got this value as 0.866. So can you tell me which is the answer? Yes, strong positive correlation is the answer. Okay, yes. Then what is the R squared value of the model obtained in Q1? I'll move on to the RStudio. We want to see the R squared value of the model obtained in Q1. So for that, just we want to find out the summary of model 1. So then it will give you this one, right? So R squared value 7.7516 and adjusted R squared value 0.7441. Okay, so in that case, what will be the answer here? Nearby that, okay, 7516 I think you have given, so that is the answer. Then what is the adjusted R square? Right now you have seen, you can tell the answer. Yeah, 0.7441 is the adjusted R square. So later we will be having one question, there we can see how to calculate these all. Okay, so this is the adjusted R square value. Now based on the model relationship obtained from Q1, what is the residual or error obtained while calculating the bid price of a bond with coupon rate of 3? So how to calculate the yeah, I mean you have given the answer right now. Okay, that is fine. So in that, for example, I have given for the earlier thing to calculate the adjusted R square value and all, have just given a small example. This will be coming later also. So first we'll check. Okay, so I have a set of observations like x equal to c, 80, 75, 85, 70 and 65, and y values as 85, 70, 80, 95 and 70. Okay, so these set of values are there. Okay, so this I'll just close. Okay, so x values are there, y values are also entered, and you know the number of observations is this much. So first what you have to find, SXX, so that will be sum of x square minus sum of x the whole square by n. Then SYY, sum of y square minus sum of y the whole square by n. Then xy also you have to find. Okay, so these are correlations. So sum of x into y minus sum of x into sum of y by n. Okay, so all these values I'll just run here. So here you are getting sxx is 250, xy is 50 and yy is 450. Okay, and number of values is 5. So first you want to find out the sum of square of errors. So syy minus sxy square by sxx will give you ssc, and syy minus ssc by syy will give you the r square value. Okay, so if the number of observations in the previous question was like this, okay, so if the number of observations were 5, then you can calculate it like this. Okay, since it was like number 35, we have gone directly with the RStudio, but in your exam and all, it will be coming with a smaller number of observations, maybe like 10 observations or less than 10 observations. So in that case, you can find the r square value. So r square value is right now 0.02. Okay, and if you round it, so it's a bigger value right now, so you have to round this to 2 decimal places. So that particular thing is given by round off print r2 comma 2. Okay, so you can get this r square value as here. And then there are many ways of calculating adjusted r square. So you have seen one method in your lectures, and I'm just now giving another method when you have the r square value. So it's like 1 minus r2, which is the r squared value, into length of y minus n. So length of y, anyway it's 5 actually, by length of y minus 2. That means n minus p minus 1, like that. Okay, so if you do like this and then get a round of this one, you will get the adjusted r square value also. Okay, so this is right now the value and rounded to 2 decimal places. Okay, so we'll go back to the question. So here, residual error obtained while calculating the bit price, that was shown earlier. So residual standard error 4.175 on 33 degrees of freedom. Okay, that was the, sorry, what was, okay, so this is different actually. We want to find out the residual error obtained while calculating the bit price of a bond with coupon rate. So from the previous questions, we have seen the relationship actually, bit price equal to 74.7865 plus 3.066 into coupon rate. So this you can calculate directly. You can tell me the answer. So it's written as bit price equal to 74.766 7866 plus 3.0661 into x. X is the coupon price. Okay, so this is your equation. So using this equation, now you are given with the coupon rate as 3. So you can find the predicted value for the 3, actually coupon rate of 3. Okay, so your bit price will be coming as bit price equal to, this you can calculate also in RStudio, sorry for the 0 here, 74.7866 plus 3.066 into 3. Okay, so that will be giving you a value of 83.9849. Yeah, 9845, 98, okay. Oh, okay, if you're getting that, so I got 9849. Okay, yeah, so that's fine, just the decimal point differences only. So from these values we have taken, right? Then what you have to do, you have to find out the real value of y at the coupon rate 3. So for that, you check it my data, and in that for 3 its value is 94.50. so the real value y at x equal to 3 equal to 94.50. okay, so what you have to do, you have to do y minus y cap predicted value and tell me the answer. So it will be 94.50 minus 83.9845. So the answer will be coming like, okay, one has given the answer already, but just calculate this and tell me the answer. Okay, 10.5155. So A is the answer. Okay, so if you want to calculate this in RStudio, that also we can do. So that can be done. Okay, wait. I think I have not done here, but still what you have to do is, I think I have a model here. Yeah, you can, I will copy this one and will just show you that. So for the fifth question, so just I'll give you data dot frame, it's not height, it's the coupon price. Okay, coupon price equal to 3, and right now our model is given as model 1 itself, so I will be giving that to A, and A is right now this one. Okay, so just ask like that. So result we have to give like this, sorry, model dot 1 so okay, there is a problem there. Anyway, now I'll directly give like coupon rate. Okay, so if you give like that and just print the result, you'll be getting like that, and this result. Okay, so actually the data frame should also include the y value also. So y value is like 94.3, I think. Okay, so you have to put that value minus the current value, and if you put that, so it is like the 3 value 94.40, so I had to include that also in my data frame. So 94.50 minus result will give you the R error, and if you print the R error, you'll be getting the same value. Okay, so that is the 5th question. Then state whether the following statement is true or false. So till now, is there any doubt in the calculation? If there isn't, we'll move on with the next question. Okay. So state whether the following statement is true or false. Covariance is a better metric to analyze the association between two numerical variables than correlation. What do you say about that? False. Okay. Rest of you? Okay, so correlation, yes, I think this question was asked earlier also. Correlation is a better metric to determine the association than covariance, right? As correlation does not have any unit and is also dependent on the range of values of the variables. Okay, now so answer is false. Now if R square is 0.6, the sum of squares of residuals is 200 and sum of squares of total values is 500. Then sum of squares of error is asked. This is direct question only, you can tell me the answer. Yes, 300, right? So anyway, you can give it like that. I mean, you can say like steady state, not steady state, I keep on telling that, sorry. Sum of squares of residuals is it's given like SST minus SSE, this is given. So you have the two values, it can be directly calculated. Okay, so answer is 300. Then linear regression is an optimization problem where we attempt to minimize. What is the answer? What is that we are attempting to minimize? Okay, sum squared error, that's true. So linear regression, it is a minimization problem where we tend to minimize the loss function. So loss function is given by the SSE. SSE is the loss function, or sum squared error. So it is given by minimizing. So loss function we will give. Why you have given A? Okay, yeah. So minimize sum of 1 to n, summation 1 to n, then yi minus y. This one will be the predicted value. Okay, whole square. So that is what we try to do in linear regression. So sum squared error. Now the model built from the data given below is y equal to 1.39x plus 6.09. So we are given with an equation. Okay, so already the beta 1 value and beta naught value is available. Find the values for r square and adjusted r square. Okay, so now you can see just like the equation that we have seen a little bit earlier. Now there are 6 number of observations, right? Y value also, like x and y value, there are n equal to 6. Okay, so for that what we can do is we can find sxx, syy, sxy. Then using that we can solve, and we have the number of observations as n. So using these things we can solve for r square and r square adjusted. Okay, so for this I'll just move first to RStudio because I have not directly solved it. I have solved it with respect to the example. So I think this is the equation. No, this is not the, okay, this is the question. Okay, x equal to 8.55, 0.32, 8.4, 6.96, 3.23, 8.18. This is the question. Okay, so I will just give you a link which will show you how to directly do that. Okay, so just I will paste this in the browser, and okay, so if you see that for an example they have given x and y values here. So this is calculation in Excel. Okay, so here you can see x, y, then x, y, x square, y square, that is x, y, y, all these values. First you have to calculate that, and using after that you have to solve the equation which is given like this. Okay, so s x y minus sum of x minus sum of y by this one. Okay, so similarly in RStudio, if you see, like I have shown earlier, these are the set of observations. First you want to find out sxx, which is sum of x square. So you have to find, so if you are solving it by pen and pencil, you have to find out the x square value, then y square, then sum of x and y by n, that means the mean values, and then you have to do sum of x into y and sum of x into sum of y by n. Okay, then SSC is given by SYY minus SXY whole square by SXX. Okay, then R square you will be obtaining like this. Okay, so just we will see the answer. So x values are given like this, y values like this, n equal to 6. Okay, first you want to find out SXX value. So this is the 57.8502. Okay, you can check this with if you are solving it directly now, you can check with the answer. Then SYY, okay, that is coming as 118.10935. So I'll just clear the workspace first. Okay, and I'll run this again. So SXX is coming like 57.8702, YY is coming like 118.109, and XY is coming like 80.433. Then with that we will find out SSC. So SSC is 6.27. Then SYY minus SSC divided by SYY will give you, so SYY minus SSC will be like SS R, okay, kind of like that, divided by SYY will give you the R squared value like this one, and if you round it up to 2 decimals you are getting like 0.95. Okay, so similarly, so here you will get it like R squared value is 0.95, and adjusted R square value same way like we have solved for the earlier question which I had explained with the values. So here you have to get it like R2 R square adjusted equal to 1 minus R2 into length of y 6 minus 1 by 6 minus 2. Okay, so then if you do this, okay, other form was also there. Okay, that's what I've given in the other one. So you will get it as 0.9335. Okay, so 0.93 is the answer. Okay, so just I have given the explanation, not in RStudio also. This is how you can calculate it. Okay, is there any doubt in this one? Okay, I hope there is no doubt. We'll move on to the next one. Identify the parameters beta naught and beta 1 that fits the linear model beta naught plus beta 1 x using the following information. Total sum of squares of x this much, sxy this much, mean of x and mean of y also given. Okay, so you have to find out beta naught and beta 1. So this also is another form in which you will be getting the question in the examination directly without any x and y values. So for this one, the solution is beta 1 you can directly find out with sx xy by ss xx. So 52.1 by 52.53, the answer is this much, and beta naught equal to y bar minus, that is the mean, okay, minus beta 1 x bar. So this is the answer. Okay, so it's like values of beta naught is 1.9 and beta 1 is 0.99. so the first one is the answer. Okay, so answer 1.9 and 0.99. okay, so now we'll move on to another question. So this is like x and y values are given, minus 2, minus 1, 5, minus 5, 2, then y values minus 3, minus 4, minus 10, 0 and minus 7. So till now the questions which were given were of the previous course. Okay, these are some extra questions. So you have to find out whether it is positively or negatively correlated. So for this you can use the correlation formula, or I have directly solved here. X equal to this one, right, and y equal to minus 3, minus 4, minus 10. So find the correlation COR of x comma y. It's coming like minus 1. Okay, so in that case this is negatively correlated. All right, answer is B. Now a model is built from the data given below. Y equal to 0.2x plus 60. Find the values for r square and adjusted r square. So you can see the values as this one. All right, so we'll move on to RStudio once more, and this is similarly you can just give the values for r square. Okay, so this is the equation. Okay, 80, 75, 85, 70, 65. So for this you have to find out x minus x bar, y minus y bar, then you have to predict using this equation, then y minus y cap the whole square, all those things you have to find, and at the end you have to find these three values and then find the r square. Okay, so directly I'll give the entire thing because it was solved just moments before. Okay, so you will get the r value and r square value and adjusted r square value like this. Okay, 0.02 and 0.3. so just below I have given another form of finding out r square adjusted. Okay, it will give you the same value itself. Okay, so it's like r square value is 0.022 and adjusted r square is minus 0.303. Okay, now we'll move on to a new data set. So following set of questions 5, 6, 7, use the data set women.csv. This data set contains two variables, height in centimeter and weight in kilograms. So what is the relationship between the variables height and weight? Okay, similar to the one earlier. So I think, yeah, this is the one. So you can use the choose file option also, or you can do like this. Okay, so it's already present in this path, so I have given this path. Okay, so the what thing you have to make sure that you are using the forward slash. Okay, usually in your system it will be giving like a backward slash, so you have to replace it with the forward slash when you are giving the path. So another option instead of using this one is to directly give file dot choose. Okay, so anything you can do. So this particular data is like this. Okay, height and weight values are there and about 15 observations are there. Here also there is an extra column giving the serial number. Okay, so what we will do is we will look at this path and give read.csv since it's a CSV file, and this is a whole path. Okay, and okay, sorry, it's still here only. Okay, so this is the thing. Okay, if you load like this, then you will be getting, I have read into data, so data will be coming like this. One x value, one extra column is there for the number of observations, so that you can avoid by giving row dot names equal to 1. Okay, so if you give that and give the value, then you will be getting like height and weight, simply that too. Okay, so that, and with that we will see a model. So since our question was what is the relationship between the variables height and weight. Okay, so what we will do, this model is there, so we will be forming the model with the equation weight till height, data equal to data. So the model, if we print the model, it will be showing these things. Okay, coefficients, intercept, and as well as the height. Okay, now if you want to just see between these two values how the values will look like, so you can just give the values like plot. Okay, so from this I'll take the initial one, maybe just the plot. Okay, so what I will do is that okay, I'll just do it from here itself. So here I will just give like this. Okay, so right now it's in this form. Okay, so if you are giving in it in that, okay, and just plotting it once again, you can see the height and weight regression. So right now in the previous case when we were plotting, I haven't shown this thing earlier, so we have to put the x and y values like my data dollar coupon rate and my data bid price like this. So if you have already given it in the model and right now after that you are plotting, then it will be directly stored like in this values. So you can see the weight and height here, and there is a line passing through the middle, right? So I have given the data observations in the color blue, and the rest of the things I have given the title height and weight regression, a regression between height and weight, Then I have given the AB line, so that line is given by this model. Okay, so it will fit a line here with respect to these values. Then I have given some margins, etc. Okay, so that is not necessary, it's to give some what you say, values. Okay, so that, okay, I will just give you the plot. Okay, so in this one, or so these are the different parameters that you can get in a plot. Okay, so in the arguments you can see these many different plots. Okay, so in this you can see like this is like if you want to change the size. Okay, just I'll come back to the plot. If you want to change the size of the symbols and text, it's like this. So if you give it like 0.8, this size will reduce. Okay, it's not an AB line, it's in plot. Okay, you see, this is the whole thing. AB line is another statement in plot. Okay, CEX is for changing the argument within the plot. Okay, then the other one is like PCH is there, so it is like to set the character, that is for the characters. And likewise another thing is this, the color. All those things you can change, but these things are not required. If you exclude this also, it will directly form, this plot will form. Okay, then so this is the plot which you are obtaining. Okay, this is the distribution. So for the previous case, for our bonds data, I think we didn't plot that. If I just read that and give that, and if I just plot it, then this is the plot for the coupon rate and bid price. This is different from the other one. Okay, now we'll move on to the next question. So relationship, we have seen the intercept as well as the beta 1 value, right? So it is given here minus 87.52, so it's like negative intercept is there, and the height beta 1 value is 3.45. so if you see here, weight equal to 87.5167 in plus 3.45 into height. Okay, so this is how you find out. Now what is the R squared value? Just wait a moment. So what is the R squared value of the model obtained in Q5? So this is also a connected question. So we have, okay, I'll just read that model once again. Okay, so if you give summary of model 1, the whole summary including the residuals, the coefficients, their standard error, then t statistic value, significance, whether to reject the null hypothesis. So here if you are giving this particular level of significance, then you can reject the null hypothesis that beta 0 equal to 0, then intercept is significant here. And this one, if you are considering it like that, then beta 1 is not equal to 0, that means this also has to be considered. That's why our equation is coming like minus 87.51667 plus 3.45 into the height. Okay, So the standard error, everything is there. So in our question, R squared value is asked. So R squared value is given as 0.991 and adjusted R square is 0.9903. Okay, so 0.991 is the answer. So it's written here, the snip from the R Studio is given right now. So the R squared value for the model fitted between the variables weight as y in kg and height as x in centimeter is found out to be 0.991. Okay. Now on the model relationship obtained from Q5, what is the residual error obtained while calculating the weight of a woman with 69 centimeters? So this is similar to the question earlier when the coupon price was given like 3. So I have taken the model from there here also. So A, I am putting like a data dot frame 69. Okay, so just we'll check the real value for what the data in the data what it looks like. So data is this one. Okay, so right now we are asked with 69 centimeters. So 69 centimeters, sorry, 69 not centimeters, I have made a mistake there. So actually this value is lying very far from the data ranges actually. Okay, so this is actually, don't look at these values. Height is, it should be like weight should be here and height should be here, but the initial CSV file is like this only. Okay, the file which was given is like this, so don't look at the significance of it in reality. Okay, so here you can see like 69, anyway the data is given like that. So 69, for that 150 is the value. Okay, so first I formed a data frame A, then I am using the model 1. So right now model 1 is predicted in a linear regression case like this one with the intercept and other value, height as this one, b1 value, beta 1 value is like this one. So with that I'll predict. So it is stored in result and result will give you 150.533. So in the original entry in the data set for the 69 value, the value given is 150. Okay, so in our studio we are giving like result minus 150 and then print the error which is 0.53533. Okay, so here the residual error obtained while calculating the weight of a woman with height 69 centimeters is this one. Okay, so this is the calculation, predicted value minus actual value. Actual value is 150 and predicted value this much. Okay, so you have the equation, you can do the calculation like this also and find out the value. Okay, just wait a moment. Now certain practice questions. The higher the value of R square for a model, the observations are more closely grouped around. Can you tell me the answer? Okay, yeah, the best fit line. That is true. Now the standard assumption of ordinary least squares regression is that there are errors only in the measurement of dependent variable. Okay, that is true. Yeah, or if you are giving there are no errors in the measurement of independent variable. Okay, there should be no errors, but now right now it's given like there are errors only in the measure, so that is not true. So C is the answer. Okay, now the relationship between dependent and independent variables in a simple linear regression is described by yeah, that's true, coefficient and intercept. The Pearson's correlation coefficient between two parameters is calculated to be 0.10. What can be inferred regarding the relationship between the two parameters? How is the relationship? A, B, C, D. You can give the answer. Okay, there is a weak positive relationship between the two values. Okay, then standardized residuals have t distribution with n-2 degrees of freedom. That is true. Okay, so I think this is for all for this week. So if you are having any doubts, you can ask now. I think in the previous courses the assignments were all very straightforward also in week 6. So if you are having any other questions, you can ask. Okay, can you just tell me what is known by a predictor and a response variable? In the lectures you have heard, no? Like, I'll come back to the slides. So, you have mainly two types of variables, like either like it will be independent or dependent. Okay, so based on the number of independent and dependent values, it will be like univariate or multivariate problem. Okay, and based on that, if you are trying with a linear regression problem, then it will be univariate regression or multivariate regression. So right now, if you see the predictor and response, okay, this is another word. Predictor is another word for independent variable, and response is another word for dependent variable. Okay, I think this was explained in the lectures. Okay, there are many other different variables. Yeah, okay, yes, yeah, that's all. So just create the predictor and response variable. If it's given like that, then it means that x value, that is the independent variable, and y value is the dependent variable here. So relation. So now if you give like that, you have already seen this, the summary of this particular relation will give you all the details of this particular value. And plotting we have already seen. Okay, so another thing is like, if you want to give the chart file a name after plotting, you can do that. Okay, so if you just go back to your folder, current directory, then you can see the plot which was already formed will be saved to that particular location. Okay, so you can use this command png if you want to store it as a png file equal to linear digression.png if you want to save the chart in that particular value. Okay, so right now, earlier the plot which was formed earlier, which is of the height and weight thing. Okay, that's why that got stored. Okay, now another way to save the file, then if you want to plot the residuals, okay, so then relation dot residuals will give you the residuals, then the character size and the color. So if I run this particular thing, you will be getting like, okay, okay, relation is right now this one, and if I am plotting the relation, oh sorry, okay, so right now why is this not plotting? Okay, just wait a moment. So this is the residuals in the relation. Okay, so I'll just give like this. There is one problem. I didn't change the values. Okay, plot is not right now coming. Wait a moment, some problem with that. Just I'll try with something else if plot is working. Okay, just wait a moment. Okay, so we were running at this one. Okay, yeah, this was the question. Now if I do just the plot of the residuals, okay, so it was not responding earlier, so just wait a moment. So this is the residual plot, okay, of this particular question, and the relation was already found. For this particular question, the intercept is minus 38.55 and the beta 1 value is 0.67. So the equation will be y equal to minus 38.455 plus 0.674 into x. So with that we will calculate the residuals. That means the yi value minus the predicted value. So for all the different x values, these are the residuals which are coming. Okay, so that is with that. So I'll just discuss some other things which were explained in the lectures. So this is for a two-side test if you want to find the quartile value for a 95% confidence interval. So wait, I'll just run the previous things together. And okay, so that is coming. Okay, so if you want to find out for a 95% confidence interval, so it will be like two sides, so 2.5 like that, it will be shifting. So 0.05, so in that if you see 2.0345 will be the value. That means the value which you are getting here, for example, the value which you are getting here can vary with plus or minus this value. Okay, so if you are getting a particular y value, it can be that value minus this one and that value plus 2.043. so that is calculated right here. So here you can see that for this particular thing, the coefficients, intercept and coupon rate. Okay, so 3.0661 is, so I think I have given it 2 times. Okay, just wait a moment. These are the two different forms of doing that. So again, so right now you can see intercept and coupon rate. Okay, that extra thing has come because I have assigned it 2 times. Okay, so this is the value for 95% confidence interval. So confidence interval for beta 1 will be, so you found out like the estimate is this much, right? And this is the standard error. So how to find this error with this error? So you have this variance with for beta 1. So 3.0661 minus 2.034, which we found out from this, into 0.3608 will be one of the values, will be the starting value of the beta 1, 2.44, and this one 3.0661 plus this one value will be the variation up to which beta 1 value will vary. So you have seen that if this value, if these two values includes a 0 in between, then you have to accept the null hypothesis, but in this case it doesn't include. Okay, so you are rejecting the null hypothesis, and that means you have to consider beta 1. That means if you are rejecting the null hypothesis there, then beta 1 is not equal to 0. That is the alternate hypothesis. So how you will find out is given that the interval does not include 0, so that means beta 1, b1 here means that beta 1 is significant. Okay, now finding out the SSE value. So this is how you can find out. So just F statistic, how to calculate, it's already available from the model, but if you want to calculate it differently, okay, you can first find out SSE, which is sum of my data bit price. So my data bit price will be there, this many number of observations, and the fitted values will be the predicted values. Okay, this much predicted values are there. Sum of this will give you the sum squared error as 575.3418, and sum squared residuals is this much. Okay, the n value is 35. So if you do like this, then you are getting the F statistic value 99.87. so you have calculate like in this way also, and if you get the summary of the model also, you'll be getting the same answer. Okay, now residual analysis was also taught, and how to reject a particular outlier. So just I'll explain that also. So plot model 1 fitted values and R standard of model 1, the main value this one, X lab, Y lab. Okay, this one is the plot. So you can see here 3 outliers, mainly 3 outliers are there. So if you put identify this particular one, you will be like, you can select one particular value. Okay, I mean you will be getting like no point within 0.25 inches, and if you select another particular value, then nearest point already identified will be coming. So just I'll be showing you some values. So right now I have got one particular value 4, all these 3 values are not there. Okay, so right now I have identified only one. Okay, so just I will put that particular value I am rejecting from that. Okay, and now if I am seeing the relation as well as doing the identify again, it will show you this one, and summary if you see. Okay, wait, summary if you see, the F statistics has changed to 107.8. Earlier when you saw the F statistic, it was 99.87. so when one of the outlier, that means 4 was removed, minus 4 means 4 was removed, so the F statistics has increased to 107.8. so this, in this way you can reject the outliers and calculate the summary of the model, calculate the fitted model and all the statistics for that particular model again. Okay, so any questions in this one? So if there are no questions, I think we can end the session for today. Any other different questions that are coming in your assignments also, you can tell. Okay, then I think there are no other questions for today, right? The attendance anyway is also very low. If anyone is having any questions, you can just ask now. Okay, then everyone, we'll stop the session for today. Okay everyone, have a nice rest of the day, and I'll see you next week. Okay.